Hi guys, let's start with Python coding again today. So let's type online Python editor on our browser, go to the first link, and then we'll start coding. So last time we introduced lists and tuples and some of the list methods or functions which are defined within the list class or within the class list. And so we are going to continue working on lists today, and we'll provide a bunch of new methods for lists to work with, and also do some problem solving using the concepts we have learned so far. So suppose I have a list. I can just name it li, and I can just have a bunch of numbers 1 2 3 4 5. You can also have some uh, strings, booleans, and so on. Now we can do certain operations on that. I can make a copy of the list. So list equal to li dot copy. If I do a copy and then print a list, I can say print list and run. It just made a simple copy of this. We can also do, so we can clear the list.clear, and it's just gonna take away everything. Nothing will be printed there because there's no list left now. The next important thing we can do is, suppose I insert 1 over here, and I can just count the number of ones that appear in the list. For example, we can say list count 1, how many times 1 appear, or how many times each element appears in the list, so that we can do using list.count. There's something going on with this compiler, but let's try again. Yeah, so let's try to see what happened there. So we counted the number of ones. Okay, so print li dot count 1, it just provides 3. If I say how many 2's are there, it provides 1. How come we have 3? And if I say number of 3's, uh, number of 3's is 1, and number of 1's, how come it's, oh yeah, the number of ones is 3 because true is also counted as one value, because true corresponds to 1 and false corresponds to 0. This is also apparent from here. Suppose I have a variable, say bool1, and we call it true, and then you have a variable bool2, we call it false. And now if I say c is equal to bool1 cross star bool2, so I'm multiplying the boolean1 variable with boolean2 variable, and if I say print c, this is gonna just provide a value of 0. The reason is the true is considered, the real value of true is 1, the value of false is 0, and if you multiply 1 by 0, you're going to get 1 here. We can try to do other things over here. So suppose if I want to say bool1 plus bool2, yeah, what does it give me? Yeah, 1, because 1 plus 0 is 1. And if I say bool1 divided by bool2, this will give an error because your bool 2 is 0. So if you divide something by 0, it's an infinite number. It just it gives 0 division error in computer programming usually. So that's how the boolean variables work. That's why when you have a true in your list, it's just going to count it as 1, and that's why the counts of 1 is coming out to be 3. So 1 is coming 3 times over here, and as a true. And suppose I just say false, and then if I just count the number of zeros here, it's gonna give me 1 because false is actually 0. So we can also do other things. Suppose I have another list li1. What we can do is just 1 2 3 4, and if I say li dot extend and say li1, and let's see. Oh no, uh, what we have to do is we have to just execute this first and then print li again, and it just extends the list. It adds the two things in the list, and that's called list extension. Let's try this. Print li plus li1, and yeah, so the only difference 1 2 3 1 2 1 3 4 5, then and false, and 1 2 3 4. Oh, it extended it twice in first case, and in the second one it just added the two numbers in the list. Let's try it again. List li dot extend, and simply say this. No, it just takes one argument, and if we do the reverse way, li1 dot extend. Oh, the reason it is doing it is because it's taking a value of li from somewhere. Extend and say li, and just get rid of this and say li1, and here you go. So this is your original list, and 1 2 1 3 4, this is your final list. So when you want to extend list with another list, you do this. And now you can also do the same operation, I believe, by not doing this and just saying li1 plus li. What happened there? Oh, li. Yeah. So there are two ways of doing the same thing. You can either extend the use list.extend, or you can just concatenate the lists. But you can also do another thing. So what we learned is list.extend, and that works in two lists. You can also say list.append. So what list.append is going to do is it just takes away, you just give a number here, suppose 5 or 6 or whatever we don't have, and then we can say print li. So what it does is it just adds a number at the end. So if you want to add one element to the list, you will say list.append. But if you already have a small list, and if you want to add that list to the other list or concatenate the lists, you will use list.extend. So these two functions are really useful, list.extend and list.append. And suppose there is another function called li dot index of 6. I want to print the index at which 6 is present. We can predict the output here, so let's count the index of 6. Okay, let's put 6 here because we at that time we appended it earlier. So this is 0 index, 1 2 3 4 5. This is sixth element, 7 8. So it should have an index of 8. That's right. So it just printed the index for you. And we can also try to do sorting. So say li dot sort, And if we try to print li again, because the list is sorted, what happened there? Li dot, oh, the reason it's not working over here is because we have string data inside. Let's see if it can accept the boolean. Yeah, it accepts a boolean false. The value false is 0, and then it just provides the whole list in order of the numerical values. And one can also say remove list dot remove and say if I want to remove false, and then we can print the list, the false is gone. And then we can also calculate the min or max, so we can say list dot min and print it. Let's see if it works over here. And list dot min is, oh, no, it doesn't work like this. It's min of list. And how, let's close this. So the min, the lowest value is false, because the false value is a boolean value of 0. That's why that's min. You can also do max, and that's a 6. That's right. And these are some of the list functions. There are other functions, uh, and let's try this. Insert a value of 8 at an index of 0. Yeah, it works. Print li, and what did it do? Li dot insert. Oh, so at index number 8 it gave a value of 0, so you need to give the index. Suppose if I say 0 and 8, now what does it do? It just gives 8 at the index 0. So we learned a bunch of list functions today, starting from insert, extend, append. Extend is joining two lists or concatenating this, and append is adding a new element to the end of the list. And then you can also say remove. You can remove some element from the list. Last time we did pop, it removes the last element from the list. And you can sort the numerical list. You can get the min and max from the list. You can get the lowest index of the element. Suppose I have some, this one is repeating twice and I want to find the index of one. If I use the index command, it's gonna give me the lowest index of one. There are two indices of one, 0 and 2, but it's gonna give me the lowest index. And these are a bunch of list functions that we can use. But there is another important thing which we are going to learn today. That's called a for loop, and a for loop is really useful. It's useful for all these kind of iterable data types. It is useful for strings. It's useful for lists. It's useful for other data types like tuples and dictionaries and other things. We are going to go through them later. But let's see how list works. Suppose I want to do some operation on each element of the list. So suppose I want to just square each element of the list. So what I can do is for I, so one way, let's try to see this. If I say new list is equal to list star star 2, let's see if this works. This doesn't work, because what I was trying to do is I was trying to square it, but it doesn't work. So the way to do this is, suppose you use a for loop, and there are elements in the list. Say if I say for I in list, it's gonna take each element one by one and do an operation there. So I will say I is equal to I star star 2, and let's try to see if this works. This is a simpler operation, but we can have more complicated operations. I is equal to I star star 2. So what we can do is, I think this is going to demonstrate it better. So we create a new list. The way to create a new list is whenever you want to initiate a list, you create a new list. So what I'm going to do is I'm going to pick each element of the list, do a square of that element, and then we can just say list dot append. uh, So we'll just give it another number n and say list.append n. And let's see if this works. This is going to work, and then we can print the final list. Print list, and yeah. So, and then we can also print your original list. Now let's discuss what happened here. This was my original list, and we can also say the new list is, and the original list is. Okay, so this makes things better. What we did over here is we used a for loop. We picked each element from the list. So when I use this in over here, this in command, what it does is, if I say for I and li, and you need a semicolon over here, a colon over here, and when you enter this, all of this is under this for loop. That's why you see an indent over here. So this is a for loop over here. What we did was we picked each element of the list one by one. So essentially it's more like a for each element in list. I took that element and then calculated its square, and then appended that square into the new list, which I created as an empty list. And this is what we discussed just moments back. There is an append statement and append method. What it does is it just takes an element and adds it to the list. So each time if I print the list over here, if we can also say print list within our for loop, each time when I print the list is gonna the list is gonna get a new element here. So look at this. So the first time the list was empty, we can also print this list over here, and it's going to show you. So the first time when we had this variable list, it was empty. First time when the loop ran, it accessed the first element with index 0 from original list li, and then squared it, and then appended it to our list. So when the loop ran for the first time, it got the first element, then it ran the second time, got the second element, then it ran third time, you got the third element appended in the list, then fourth, fifth, sixth, seventh, and so on and so forth, and finally you got the full list over here. Now when you're printing, when you're using this print statement inside the list, it's going to tell you how the whole process of progression is going on. But if you use the same print statement outside the for loop at the end, so it will show you what happened at the end, and you get whatever is available then. So this was your original list, this was your final list. You can also do this. You can say print list, and it will show you the starting, it will show you the process ends over here, and then it shows you the final list. So this is a wonderful statement. You can do a bunch of operations using for loop. Let's try to learn few more use cases of this for loop. What we can do is, for example, I have a list, I created a new list. I can say, what I want to do is, suppose I just want the even numbers. I want to take out the numbers uh, that are positioned at even numbered index or 0. So this is the 0th index, this is the first index, second index, and so on and so forth. So the numbers at the even indexes are, okay, so let's count 0 in this and this and this one and this one. So I want to create a new list. My question is, so you are given a list li, create a new list lis, and append only the elements present at even number indices in the original list li. So what I'm going to do is I'm just going to pick up the numbers with the original, the numbers that are present at the even numbered indices in the original list. So we can use a for statement for I in li. Now I is my element, but we want to find the index right now. So if I say for I in li, this means I'm just accessing each element over here, 1 2 1 and all, but I want to access the index. If I want to access the index, this doesn't work like this, because right now in my question what's being asked is I want the elements present at the even numbered indices. I don't want the elements that are even. I don't want the numbers that are even. I want the numbers that are present at even number indices. Suppose this is present at the 0th index, this is present at the first, second, and so on and so forth. So I want these elements. So if you use an in statement over here, it's going to access the elements directly. But if I want to access the indices, then I will say I in range len of li. Now len is another function which I did not discuss till now. Len is going to give you the total length of your uh, list. So the length of the list is the total number of elements, 1 2 3 4 5 6 7 8. So the len of list is 8. I can actually show it and print it for you to demonstrate that how you calculate. Say print len of list. Now it's going to give me 8. So what I can do is, if I want to access the elements directly, I will say for I in li. But if I want to access the indices, I will say for I in range len of li, which means that what we are doing is we are starting from 0th index, we are doing stopping at the last index, and we are doing an increment of 1. Actually, this is what it is. By default, this for loop starts at the 0th index. We don't need to write this. By default, the increment is 1. We are accessing all the elements, that's why we don't need to write this. So we just tell the list where we are starting and where we are ending. So this is a range function. When you use a range function, you can access the elements of the list. There is another way of accessing the elements of the list and the indices together. So now this thing, it's very important note. What it does is this accesses the indices of the elements in the list. There's another way of doing this, but if I say for I in li, now this time it does not access the indices, it accesses the elements in the list. Now in this case I is the element, and in the previous case, in this case I is the index. I mean, this statement for I in range len of li is accessing all these numbers. This is really important to understand. On the other hand, in this case, oh, sorry, this is the index. In first case, it's index. So this one is accessing all the elements of the list over here, and this one is accessing the indices. Indices are 0 1 2, 3, 4, 5, 6, 7, 8. So I have 8 elements in the list. So this one will access the indices, this one will access the elements, and there's another one. If I say for I j in enumerate li, and what this is gonna do, so this is gonna, what it's gonna do is it's gonna accesses both, where I is the index and j is the element. So if I want to access the elements, only I can say for I in li. If I want to access the indices, I will say for I in range len of li. If I want to do operations with both I and j, you can say for ij in enumerate li. So these are three really important things to keep in mind: for I in range, for I in, and for ij in enumerate. If you learn these three things very well, I don't think you will have any problem in working with list operations. Okay, so I'm just going to delete these things and make the thing simpler. But before deleting these, I'm just going to delete their explanations first, so that you just have a real good visual input for these. You just see them really well and then just put them in your mind. So suppose I have these. I'm just gonna get rid of all this and let you see only these three. So when you say for I in range, this, what it's going to do is it's going to access the indices. For I in li, it's going to access the elements. For ij in enumerate li, it's going to access the element, the index, and the element. So in this case, what I'm going to do is, my problem is I am given a list over here. So let's get our list back. So this is my list. I want to create a new list and append only the elements present at even numbered indices. Now I want to access both things. I want the elements and I want the indices. So I think the best function to use over here is enumerate. I'll also tell you the other way later, how you can solve the same problem by using this all I in range. But this is not going to be relevant. This for I in li is not relevant, because there's no way, if you say I in li, you can't access the indices. So let's get rid of this. But these two can solve the problem equally well. Let's solve the problem with one of these first. Let's get rid of the enumerate and solve this problem with this. So what I'm going to do is, I am going to create a new list, and what I'll do is, for I in range length of li, and you need to remember the index, because whenever you have a colon over here, you have to remember the indentation. I'm sorry. So you need to have indentation. So for I in range length of li, what I can do is, I will do a conditional statement. If I is an even number index, so this is a definition of an even number index. So when you divide the index by 2, the remainder should be 0. Now this is for this, this is a symbol for calculating the remainder in Python. So if either my index is even or my index is 0, because I want to start from the 0th index and I want to pull these numbers 1 1 4 false, and that's it. So if this is what, then what I can do is, now I have the index. So if I said, if my index is either 0 or even, now I want to access the elements. So what I will do is, I will again define a new variable n and define it as uh, m sorry li I. So this is a way to access the elements way. So if in your for statement, if I is the index, clearly the I is index over here. So I is index. If I is index in your for statement, then the name of the list and I in square brackets will access the elements of the list. Okay, so this is what we need to learn over here. If I is the index, the elements will be accessed like this. So if my index is even or 0, then this will be my element and I'm storing it in a variable n, and then I will do the same thing, list. So I have a new list, I will append this element and in this. We can do it directly also. We don't need to define a new variable. What we can do is I can append this element directly into this new list, right? And then I can just simply print the new list. Print list. Oh, what happened there? Oh, I'm sorry. I need to comment this all text stuff there. Yeah. So what I got was I got this 0th element. I got this element at index 2, element at index 4, uh, 4, and element at index this one. So 0th index, 2nd index, 4th index, and 6th index, right? So this is what I got right now over here. So this is a really simple program if you look at this. So I'm just going to club this all together and show you that it's all 5 or 6 lines of code. So what I have used over here is but there are many concepts which have come into play over here. I created a list. So we need to pay attention to this, because right now what we're doing is we're kind of tying up everything whatever we have discussed and using this for problem solving. So the first step is I created a list. Second is I created a new empty list. So this is a kind of algorithm. Then I accessed the even number indices of the first list or the original list. Then I appended the elements corresponding to the even numbered indices into the new list, and then I printed the new list, right? So this is what I did completely. There's another thing, yeah, so we have to learn the enumerate function after this, and let's see how enumerate function does this. So it's very simple actually. You, rather than saying this, say for I j in enumerate 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 li. If I, now I is the index, then we can say list dot append j, and it's going to give me the same answer. Why? Because the in earlier case I was accessing the elements by li of I, but if I use the enumerate statement, this I is my index, j is the element. I can just say append all the elements that are present at 0 or even number indices into the new list, and that's how you do it. It's really simple. So what we have learned so far today is a really important concept. That's a for loop. And for loop, so we use the for loop for three things. For loop for accessing only the elements. So I will say for I in is really important, list. So probably I'm intentionally not using the word list because list is a reserved keyword in Python. So just say list, and this is a way for accessing only the elements. For accessing both the elements and their indices. Both the indices first, I think you should need to remember it this way, and their elements. There are two ways. First method, for I in range len of li. You can also change the range over here. As I said, if you give the first number, so this starts with the first index and this is the last index, and you can also say the increment 1 or whatever. So but this is a bare least, and then you can say for I in range len of li, and you can access indices from I and access elements from li of I. And the second method is it's a great idea to take a screenshot of something like this and then hook this in your mind. The second method for accessing both indices and their elements is, oh, this for is not going to work. This is a for that's going to work. Python is a case sensitive language. For I, j in enumerate li, and I can say you can use access indices from I and elements from j, right? So you can do any of these things, and if you just hook these up in your mind, it's really useful. uh, these for loops are very useful for any kind of iterable data types like tuples and other things, and even strings. So let's do one string example. Suppose I have a string over here. String is equal to, and a little brown fox. So everything together. That's a simpler example. A little brown fox. And what I want to do is I want to do alternate characters of the I want to make the alternate characters of the string in uppercase. We did something like this earlier but without loops, and that was quite clumsy. We had to write a bunch of code lines in, I think, video number of 2 of Python coding. Let's see how a for loop can help us over here. So let's first pose a problem and think about the problem. The problem is, capitalize the every alternate element of the string starting from the first element. And I shouldn't call it str, that's a reserved keyword in Python. Let's call it string. So this is my original string, and this is my final expectation or output. My expectation is that my string should look like this: a l I T T, no, small I, caps T, small t, caps L, small e, caps B, small r, caps O, small w, caps N, small f, caps O, small x. So this is what my output should be. Now I need to write a program to do this automatically. So this is my string. Now let's get rid of all the extra stuff that we use just for explanations. This is my string. What I can do is, the way I was accessing the indices, we discussed this in our previous videos, that you can access the indices of a string also, and this is a 0th index and first and so on and so forth. So the idea is, what you can do is, for what you need to do this time also, we need both the things. We need the element and we need the index because I need to find the even number indices or zeroth index, and then take the element and capitalize it. So what I should do is, for I, j, I think the best thing is to uh, make a habit of using enumerate. Enumerate li, and what I can do is, oh no, this is a string this time. I'm not sure if enumerate works for strings. I think it should work equally well for strings. Let's try. Otherwise, we can just use a range function which we learned. I never tried this, but my hunch says that it should work. So if we use the conditional statement that we learned in the previous video number 3, that if my index is either 0 or if my index is even. So this is a Python language. That's how Python speak. It's a little bit of different, but I can read it like this. If my index is 0 or if my index is even, and I can say string dot no, so j dot upper. Now in lists we started with an empty list. So in the same way we start with an empty string. So new string is equal to start with an empty string and then concatenate. So then we will say we did the j dot upper, and then what we do is we just assign it to something else, or we can just say add it over there. New string equal to new string, original new string, whatever new string was there, plus j dot upper. So we took that thing, the element at the 0th index, and then added it to the new string which was empty, but then this will be added. Now this thing, this is very important, this can be written in a shorter form. We will say new string plus equal to j dot upper. So this line number 12 and 13 means the same thing. So let's use a short notation and read it like this. New string will be equal to new string plus j dot upper. Now what this has done is it has taken this empty string and added the element at the 0th index in the first iteration, and then it will add the element but it made it upper first. So what we can do is take the 0th element at index 0 or element at even index, make it upper and add it to the new string if the element is at the even or 0th index. Else, if the element is at some other index, just add it. New string equal to plus equal to j. So you don't need to make it upper. So now this is gonna execute all together. It's not that it's only gonna take the even and 0 indexes and then it's gonna take the odd indexes. This is a whole block that's gonna execute together. So what it has done is it has just taken the indices that are 0 or even and got the element after making it upper, I mean capitalizing it. If the elements were not at even or 0 indices, it just took them all together and it's just appending it to the new string. And what you can do is at the end you can say print and say new string, and let's see if it did its work or not. Oh, what's going on over there? New string, and there is really something wrong that's going on. Okay, so let's try to debug. This is another thing that's really important. uh, we have to make a habit of debugging, and let's see if it is printing the indices. Print j. So let's first find out if the enumerate function works or not. Yeah, it works fine. So it just took each of the element over here, so this means there's no problem with the enumerate function. Oh, so what's the problem? I kind of understood what's the problem. what we have done is we have defined this new string under the loop. It all, in each iteration it just keeps getting emptied, and then it's filling the new number. That's why uh, we could only find the last number n there. Everything washed away. So it's really important that we should put it out. Other than that, there's no problem with the code. Let's make sure our indices are fine. So the way to making sure this is fine is just put an enter and it's going to take it to the right index. And yeah, so that's how it worked. It just said a little brown fox and alternate. You can do a bunch of other examples over here. There are lots of problem solving things you can try with this. We are gonna do a separate video on problem solving with whatever we have learned so far with the strings and lists, and probably some of the things with tuples. I think whatever operations we learned with tuples, a lot of those operations, whatever operations we learned for lists, a lot of them work equally well for tuples also. So I think what we did was we learned a very valuable tool called for loop today, and it needs a bit of practice, but it's a wonderful element in Python, and it can help us do a lot of stuff rather pretty quickly with with very few lines of code. So I'm gonna stop here and let you guys grasp this important concept, and maybe just try will let you try to just make some problems for yourself and then solve them using for loop with lists and indices. And the next video I'm thinking of just having a problem solving video, we will use the concepts learned so far and apply them to solve some supposedly real world problems. And I'm gonna end here, and thank you very much for your attention.